Okay, 7th grade lesson 10.2, one of the things that we will do is use proportions to make inferences about a population. Now on 10.2 form number 1, it says this: a manufacturer fills an order for 4,200 smartphones. The quality inspector selects a random sample of 60 phones and finds that 4 are defective. How many smartphones in the order are likely to be defective? So since we have a random sample here in number 1, because we have a random sample, we can make an inference about the population. Okay, so let's look at our random sample. In our random sample, we had 60 total phones, right? 60 phones in the sample, and of those 60 phones, how many were defective? What does it say? Well, it says 4, right? 4 defective phones out of 60 total in our sample. Okay, now because this is a random sample, this random sample should give us an accurate representation of the entire population, which in this case would be the total amount of smartphones. What did the problem say? How many smartphones were there in this problem? Well, in the first sentence it says the manufacturer fills an order of 4,200 smartphones. So in the population total is 4,200. That is the total amount of smartphones that we have. Okay, and we want to know how many smartphones in our population are likely to be defective. So we're looking for that unknown number right there. So what we have just done is create a proportion. Remember, a proportion is one ratio equal to another ratio. And we can solve for the unknown, right? There are two main ways that we could do that. We could say, how did I get from 60 to 4,200? What did I multiply by? Well, if I don't know what I multiply by, I can take 4,200 and divide by 60, and I would get 70, right? So I'm just basically using the inverse of multiplication, which would be division, to figure out how I multiply what I multiply 60 by to get here. So 60 times 70 would give me 4,200. And since I multiplied the bottom numbers, my denominators, by 70, 60 times 70 is 4,200, I do the same thing to the top. I multiply 4 times 70, and 4 times 70 would give me this number, which would be 280. 280. Now remember, we're talking about smartphones here. So what we're saying is that in our population, if there are a total of 4,200 smartphones, how many of them will likely be defective based on our random sample? Well, probably about 280 smartphones would be defective. Right, so that'd be my answer for number 1, 280 smartphones. Okay, number 2, I'll set up for you and then you'll finish solving. Okay, so number 2, it says this: part of the population of 4,500 elk at a wildlife preserve is infected with a parasite. A random sample of 50 elk shows that 8 of them are infected. How many elk are likely to be infected? Okay, so we have a random sample here. Because we have a random sample, we can make an inference about our population. So in our random sample, how many elk are in the random sample? Well, it says there are 50 elk. We take 50 elk in the random sample. So I'm putting the total amount of elk in the bottom, in the denominator. Now, how many of these 50 elk in the random sample are infected? Well, 8 of them, right? 8 out of the 50 elk are infected in the random sample. Okay, so here's our first ratio, 8 out of 50. We're going to set this ratio equal to another ratio of elk in the population. So how many total elk are there in the wildlife preserve? Well, it says in the first sentence the population is 4,500 elk. So 4,500 elk, right? So my bottom numbers are the total. This is my total in the sample, total in the random sample. This is my total in the population. This is the number infected in the random sample. This would be the number infected in the population, which is what I want to know. I want to know, out of this many elk, how many of them are likely to be infected. Okay, so I can cross multiply and divide, right? I could do this times this, and then divide by the coefficient of x, which would be 50, and that would give me this unknown number. Or I could say, how did I get from 50 to 4,500? What did I what did I multiply by? And again, if it's not obvious, if you don't know right away, what you can do is take this number, 4,500, divide by 50, and you would get 90. So 50 times 90 is this number, 4,500. And if you multiply the bottom times 90, you multiply the top times 90. So 8 times 90, that's going to be 720. So how many elk are likely to be infected? Well, 720 elk. So I went ahead and solved it for you, even though I said I would just set it up. But that's what number 2 should look like.